Welcome to lecture 45, Standard Template Library, we call STL, right. So, we have studied almost all the concepts in STL. So, now what we can do, we can take two case studies, right. So, one case study is about library management system, right. So, the objective of this case study is design a system to manage books in a library using STL, right. So, we used to manage books with the unique IDs and titles. So, what we can do here, we use map, right. So, whatever we have studied in this STL, we use map. So, the question is use map to store book details efficiently, all right. Then demonstrate encapsulation. So, whatever the object oriented concepts that we had studied, we are going to utilize encapsulation using a book class. Implement operator overloading for comparisons, right. It will be a very good case study, right. So, we are going to create a class with the help of encapsulation, and we are going to use operator overloading, and more importantly whatever we studied very recently, map, right, because of STL, right. So, we are going to use this map to store book details efficiently. So, let us consider the key components. So, here you have book class, right. So, this encapsulates book details, ID and title, and more recently we studied map. So, here we are going to use map. So, which will be right storing books with ID, that is an integer value, and this is the key, and the book object, title of the book, right, it is a string as the value. So, the main functions of adding the books. So, these are all the functionalities, displaying all the books and searching for a book, right. So, these are all the main functionality of the library, right, adding book, displaying all the books, searching for a book, all right. So, these are all the main functions. So, operator overloading. So, this is useful to compare the books, right. So, either by ID or some other criteria. So, we may use less than or equal, right. Some operators we are going to overload, that we will see, and then we use a default constructor, right. So, this will be useful, and in fact, it is supporting STL operations like operator. So, let us consider how we are going to implement this. So, let us consider the book class, right. I include IOStream string, usual program, right. So, let us have class book. Class book has two private member data, one is ID, right, whose data type is integer, another one is title, whose data type is string. And here you have in the public, you have a constructor which is a default constructor, and ID is assigned to 0, you are initializing ID equal to 0, and title is unknown, right, title is unknown, right. That is about your default constructor. Next one is the parameterized constructor. So, the parameterized constructor ID int, right, int ID, and you have title which is string, right, and then you are assigning ID which is equal to ID and title is equal to title, right. So, this is a parameterized constructor. Then you have accessor functions, right, get and set kind of, right. So, here in this case get int get ID, right. So, that will return ID, that will return ID, and here get title. So, the get ID whose return type is integer, and get title member function whose return type is string, right. So, this is returning title, and here you have operator overloading, right. So, the operator overloading, you use less than for operator overloading, you use return type bool and you have operator, right, and then other object is other, it is a reference whose class is book, right. So, here it will return 1 if ID is less than other dot ID, right. If this inequality is being satisfied, it will return 1, otherwise it will return 0. So, that means you are comparing books by ID, right. So, this is the class. If I am asking you to encapsulate this, you write, right, with default constructor, with the parameterized constructor, with get and set functions, you call it as accessor functions, because I can able to access ID and the title from outside, right. So, because your get ID and get title are public, right. So, these are all the public member functions. So, I can able to access, in fact, these functions can able to access ID and title, right. So, these all we know, right, and then you have the operator overloading. So, I encapsulate the complete class book over here with the help of default constructor, parameters constructor, accessor functions, and then operator overloading. So now when I use map for storing books, right? So we will see how we are going to do this. So here we use map. So the map contains integer and book, right? You have one integer variable and object book. You can have, we have seen several examples where the map, right, having more than one variable, right? So here we are using variable and object. Object is book, right? So this is used to store and manage books. And then here you have key, book ID, right? So key, which is nothing but book ID, which is an integer. And then the value, book object containing details, maybe name of the book, all right, name of the book. So whenever I am having the book, I mean, you can find it in the library. You will have the unique IDs, right? You will have the unique IDs, right? So that we have to ensure, and in fact, the map is ensuring, right? And it is providing efficient insertion, deletion, and lookup, right? So we are going to make sure that this map is providing efficient insertion, deletion, and lookup, right? So these are all the reasons we use map, right? So for storing books. So let us see how you can do this. All right. So if you recall, we studied an example, Alice, Bob, Charlie, right. So these are all the examples we had seen in the previous classes, right. So here map contains int book, and then I have an object library, right. So the library comes under the class map. Map is having integer variable and book object. So now I can add books like this, library of 1. All right. So you have book object, correct. So you are passing 1 and C++ primer, and the next one is library 2, right. You have book object, you are passing 2 and effective STL, right, and library of 3, object book, passing 3 and clean code, right. So like this I can form the map, right. I can write the map like this. So whereas when I am using the map, these are all storing the information about the books. So I can do with the help of map like this. So now adding books and displaying library. So what you can do, right. So again I am using map. Under map I have the operator, right. So the operator, I am going to overload this, the array symbol, to add key value pairs, right. So to add key value pairs, and then displaying book using range for loop. The range based for loop is useful to display the books. So here you go. So library we have already used. So here auto, the reference of entry and library both are same, and the C out, right. So here in the previous case we have, this is library, right, library 1, 2 and 3. So now they are going to map to entry, right, and then this is a range based for loop. I am going to display ID and title, right. So the library has ID and title. If you look at line number 4, 5, 6. So now library, the base address is copied to entry. So the entry will also contain all the information, and when you are printing, that means we had seen the similar example. If you look, right, first and second, age, right, and the person, Alice 30, Bob 35, if you recall, right. So in a similar way, entry dot first and entry dot second dot get title, right. So these when you print, right, entry dot first. So we know first will be nothing but the number 1 that you are passing or 2 you are passing. So that will be displayed, right. ID colon is outside, this will be displayed, and entry first is a number, and then title. So under title, second dot get title. So get title we have here line number 18, right. So that is returning title, right. So here you go, title colon we are printing. So that will be there. So it will print C++ primer or effective STL, right, with ID 2. So all these information will be printed, right. So with the help of range based for loop, so we can do this, correct. So now searching for a book by ID, all right. So we have, right, search logic. So what we are going to do, we are going to call find, right. We use find, just now we had seen, in fact last lecture we had seen find, right. So the find function which will locate a book by its ID in this case study, right. If the particular ID exists, so that will display the book details, right. So, that will display the book details, otherwise, so this is indicating that the book is not found, alright. So, let us see how this works. So, here you have int search ID equal to 2, right, int search ID equal to 2. So, here the find function we had seen, right, if you recall the find function, right. So, that will be returning the reference, right. I mean, in fact, one of the examples we had seen, that is returning the reference. So, here find search ID, your search ID is 2, you are passing 2. So, the library is invoking this find, so which is returning the reference, right. So, now when I have this library, you can have, right. So, library 1, library 2, library 3, that means library 1 is the begin, library 3 is the end, right. Again, you recall the begin and end concept that we had seen, right. You recall the begin and end concept that we had seen, right. So, in that case, yeah, here you go. So, if IT not equal to library end, right. So, it is returning. So, whether the search, so I have 1, 2, 3, if you recall I have 1, 2, 3, alright. So, search ID is 2, so this location will be returned. So, this is not the end, if you recall this is not the end, correct. So, this is the begin, this is the end, I put B and E, right. So, now if you look IT not equal to library end, true. So, it goes here found ID, IT arrow first, right. IT arrow first will print the ID, right, found ID, IT arrow first. So, it will print 2, 2 will be printed, and then you have title, title equal to, right. So, that will be printed, and here you have IT arrow second dot get title, right, the second one. So, what is the second one? So, here you go, we have effective STL, right, and then your get title. So, title will be returned. So, when it is returning, right, so you will get effective STL, right. So, you will get effective STL, right. So, STD endl, fine. So, it will be new line. If suppose, right, they are matching, right, IT and library end is matching. So, after 3, right. So, then you will go to the else part, then you can have book not found. But in this case search ID is 2, so they are not begin or end, right. So, therefore, you are getting the output effective STL. And also, right, we were talking about operator overloading, right. So, why we use operator overloading? So, here you have to compare the books, right. You may have the same copy, right, let us say 10 copies, all are same book, right. So, whether all these books are equal or the books are in sorted order in some way, right, either with the help of ID or with the help of authors, right, first author's first name alphabetically, right. So, somehow it is being sorted or the equal number of books have kept, right, in the system, I mean to say, right. So, in that case this operator overloading is useful to compare books directly, right, and also this is useful for enhancing the usability and readability of the code, right. So, this will be useful, the operator overloading, right. So, this will be useful for the usability and readability of the code. So, let us say, right, consider what are all the operators that you are going to use, right, or what are all the operators that you are going to overload. So, here in this case let us say less than or double equal to, right. So, less than, it is comparing books by ID for sorting, right. So, you have an ID and then, so whenever I have a book I may have some numbers 107, 108, 109, and then so I can compare. So, whichever is sorted, right, whichever is the minimum, I mean less than certain value. For example, I am searching for 108, I got 107, so then I can go move further, right. So, for that it will be useful, and similarly operator equal to, right. So, that is useful for checking the equality of books, right. So, here we use, let us say, one is less than operator and another one is, let us say, equal to operator, whether two books are equal, comparing, alright. So, operator double equal to book address of other. So, this is a reference object other, right. So, now I am comparing, alright. So, this will return the boolean value ID equal to other ID. Let us say two books you are comparing, or the ID same, right, you can get true, title same, true, right? So if they are true, return the value 1, right? So books are of same category or same author, right? In fact, in this case, same title, same ID, right? So it will return 1. Otherwise, if it is a different book, naturally ID will be different, title will be different, or assume the title is same but ID is different, right? Or two different authors, right, can have same title, correct? So we know the truth table, and based on that it will be returning either 1 or 0, all right? So for that we can use the usage of operator overloading, right? So sorting books by ID, also we can use set, all right? So checking whether the two books are identical or not. So we have talked about set, map, everything. So whatever STL that we have studied in the past few classes, so we can make use of these in this case study, all right? So here the key takeaways are, right? So it's a real world application. So encapsulation, so I have initially put the class and then several STL functions, right? So particular STL class, right? Several libraries of STL so have been used, maps, right? So which is for efficient storage and lookup of book details. Operator overloading, right? So either less than or double equal to, right? So for the comparison of books, operator overloading was useful, right? So here you can have the real world application. So when you are using all these concepts, particularly the STL, right? I am focusing on STL because of this chapter, right? So the library system in this particular example, so we can see how to manage books, right, or any other resources, all right? And similarly in this line you have inventory management system with efficient lookups, right? So similar kind of problems you can think about, right? So these are all the real world applications where you can use the standard template libraries. So this is one case study. So we can see one more case study, real time stock tracker, right? So very interesting problem because everyone is into the stock nowadays, correct? So if I have to have, right, the real time stock tracker, right? So for example, when you can map stock symbols, right? Apple, Google, Hindustan Unilever, Infosys, Reliance, Tata Motors. So right, so these are all some of the well known symbols. So those who are into the stock, I mean, they know that, right? So here assume that they are in the current prices, to the current prices. So now let us use an unordered map. Few lectures back we had talked about the unordered map, all right? So we use this for efficient lookups and updates. What exactly the current and then what are the updates. Next, the features include, right, the fast retrieval and updates of stock prices, all right? Also we use operator overloading, like a previous case study, operator overloading to simulate stock price changes, right? So we use operator overloading. And practical use cases is real time price tracking in trading systems, right? And apart from this real time stock, so these are all the practical use cases, real time price tracking in trading systems, dynamic portfolio management applications, right? So these are all the practical use cases, right? So now you may ask the question, why you have chosen this unordered map, right? Why you have chosen this particular data structure to solve the problem of the real time stock tracker, right? So the reason is the advantage of unordered map, right? So suppose I want to have the lookups, right? So when I have the table, I want to have certain lookups, or I want to insert certain data, or I want to do some updation, I can do it in constant time. You denote as order 1, right? Constant time. If there are n number of stocks, right, n is the very large number, so in the constant time k is very strictly less than n, right? N may be 100,000 and k may be, let us say, 4 or 5 steps you can find, right? So you can make a lookup, or if you want to insert, you can do it in order 1 time. So that is the main advantage of using unordered map, order 1, right? And unordered map, which is ideal for scenarios, right, where you may require the fast access to key value pairs, right? So you have the pair, key value pair, I want to have a fast access. So already I told it is order 1 algorithm. So that is the reason we are choosing this unordered map. And it is also automatically handle unique stock symbols as keys, right? and alternatives are map. So, you can choose map, the complexity is order log n, right. So, if you have n number of data, so approximately log n steps require if you use map, all right, or you can use vector or list. So, vector or list if you use, the complexity is n, right. Suppose I want to do for the lookups or insertions or updates, so I have to traverse the complete list, right, or complete vector, right, order n. So, constant step is better. So, therefore, we are choosing unordered map, right. So, unordered map, so which is providing the necessary performance for the real time stock tracking, right. So, when I am comparing order 1, order log n and order n, right. So, I will go for this order 1 algorithm, that means a constant time I can do, right, finding lookups or insertions or updation, right. So, that is the reason we are going for unordered map. So, what are all the components? Stock class, right. So, you can have the class, right, which encapsulates stock symbol and price, and we use operator overloading to simulate price updates, all right. Unordered map already we have defined why we are using. So, this is mapping stock symbols to stock objects, and also this is enabling fast lookups and updates, and the main functionality is add stocks to the tracker, update the prices dynamically and display the current stock prices, right. So, these are all the main functionalities. So, now we will quickly go into the program. So, here you have unordered underscore map we used, right. So, string find, that is old friend, we know that, and input output manipulation. So, these we have done, right. Only the STL part. So, we are using here unordered underscore map. In fact, we have done with the example, right. So, let us say class stock, I want to have the encapsulation. So, private member data is symbol, symbol under string, right, and the price in double, right, the price in double. So, you have the default constructor. So, in the default constructor, correct, stock, and initially symbol is initialized to null character, all right. So, you have 1 2 double quotes, that means a null character, and price is initialized to 0.0, and here you have parameterized constructor. So, under parameterized constructor you have symbol and PR, right, symbol and PR, right, that means 2 parameters you are going to pass. You are having 2 arguments over here, and SYM which will be copied into symbol, and PR which will be copied into price, right. So, this is about your parameterized constructor, and here you have get symbol function, member function, whose return type is string, right, whose return type is string, and this is returning symbol, the getter function, right. So, the getter function is returning symbol, and you have get price whose return type is double, and this is returning price, right. So, these are all the getter functions that I can access from outside the class, and when I am accessing outside the class, these functions can access the private member data such as symbol and price. So, now here we use the operator overloading. So, stock address, right, the reference operator we use plus equal to, right, operator plus equal to. So, this is going to return the reference variable, or you can say that it will return the pointer, correct. So, operator plus equal to, your parameter is changed, right, your parameter name is changed, right. So, price is equal to price plus change. If there is any change in the price, you are updating. So, this updation can be done based on the operator overloading. So, price plus equal to change. So, price is equal to is equivalent to, right, price is equal to price plus change. Change is double, price is also double. So, we know the meaning now, right. So, plus equal to, price is equal to price plus change, and then return star this. So, we know this is a pointer, right, and it is returning completely. So, assume that you have changed the price for, let us say, 3 4 stocks or n stocks, right. So, now you have unordered map, right, which contains string and stock like a book that we had seen in the previous case, right, and stock tracker is the object. So, stock tracker is an object under the class unordered underscore map. So, the unordered underscore map contains string and stock, okay. one string and one stock, right. So, stock is the class that we have defined, therefore, it is expecting one object under stock, okay. And then you have void display stocks, right. So, that is displaying simple cout set with W10, right, printing symbol, again set with 10, printing price, right. And then your range based for loop for constant auto pair, right, which is mapping onto stock tracker. That means both the reference variable, right, both base address pair and stock tracker, it is in fact the for loop, right, range based for loop. So, the base address of pair and stock tracker both are same now, right. And then you are printing pair dot second dot get symbol, right, and pair dot second dot get price, right. We will see how we are going to put this symbol and PR, right, SYM and PR, I mean to say string and double. So, here you have, here we are printing. So, we know that like the previous program, it is going to call the object pair and the second dot symbol, right, the second dot get symbol, and here you have get symbol which is going to return symbol. So, now we will see, we are coming to the main program. So, main program you have stock tracker Apple, right. So, you have an object stock passing Apple and 150.0, right, and another one Google 2800.0 and MSFT 299.0, right. And then you are updating Apple, you are updating with plus 5.0, Google minus 50.0 and MSFT plus 10.0, right. So, you are making the update, right, and then the updated price will be displayed when you are calling the display stocks, right. So, here you go, the display stocks that you have written over here. So, everything will be displayed, and in fact, it is calling the function get symbol and get price. So, when we run the code, you can see the output like this, right. So, since we have used the unordered map, so you are getting first MSFT and Google and then Apple, okay. So, and then there are some updates, right. So, here in fact, I did not say MSFT is nothing but a Microsoft, right. So, Microsoft, there is a change, right, 299 plus 10 it becomes 309, right, and Google 2750 and Apple, right, 155, right. So, the prices are getting updated dynamically using the operator overloading plus equal to, right, and then you can see the updated prices are displayed as a table form, right. So, these are all, for example, here STL point of view we have used unordered map, right. So, like this you can think of, right, and you can solve several real world problems, right. So, the key features here, we use encapsulation, we use operator overloading, right, and then we can able to use the data handling, right, the efficient data handling based on the unordered map data structures, all right. So, as we have already seen, so for the lookup, updates, insertions, it is a order one algorithm. So, that is the reason we have chosen unordered map. So, these are all the important features and the benefits of these STLs, right. So, the real time performance, these kind of problems. For example, if you want to deal the financial systems, real time performance for financial systems, scalability for large databases, right, or large data sets if you have, all right, how to deal, and clean and maintainable code structure, right. So, you can have the clean and maintainable code structure. So, if you start using these STLs, right, along with encapsulation, operator overloading, all right, make use of the property of constructors, default or parameterized, right. So, the clean and maintainable code structure will happen when you start using this STL, all right. So, these are all the other applications. So, stock trading platforms for real time updates, portfolio management systems tracking multiple assets, event driven systems for financial analytics. So, these are all the similar applications you can try to solve the problem with the help of, right. So, whatever we have discussed, right, regarding the stock, and further enhancements you can do. So, we can integrate this with API for livestock data, all right. So, that we can think of, and we are going to talk about the multi-threading and the concurrency, right. So, here you can have the further enhancement with multi-threading for concurrent updates, and also all right. You can have the implement alerts for significant price changes, right. Suppose there are price changing, right. So, we have seen some examples, right, either it is going down or up. So, we need the alerts. So, that also you can think of. So, with this I am concluding this particular chapter. Thank you very much.